They just experienced the world in a totally different way. Just saw so much more detail. And like a sunset to a Neanderthal probably looked insane. Welcome to Self-Conscious, a YouTube channel dedicated to consciousness and the neuroscience of what makes us us. We're back with Jimmy.
What's up?
We're gonna
What's happening,
hopefully
YouTube?
talk some more science stuff.
Hell yeah.
More consciousness stuff.
Hell yeah.
Specifically, I wanted to talk about language, and that's because I read this book, or I'm reading it, like only a couple chapters in. I kind of wanted to just talk about the first chapter. And the argument that he's making is that other animals don't have language, right? I would generally agree with that. Do they communicate with each other?
Oh, okay, yes.
Sure.
Yes, absolutely. Yeah.
Right. But they don't have language. Language is a very specific thing. Different symbols or arrangements of symbols that can only be arranged in certain ways. There might be infinite ways to arrange them, but only certain ways are used, right, or make sense. And you could immediately identify language if it were used in an animal based on dissecting like the phonetic parts, or even like in radio signals from space. You could theoretically identify an alien language.
Recurring, the mechanics of linguistics. Have you ever seen Arrival?
No.
Oh, that's a good movie. You should check it out. They talk about like trying to translate what the aliens are talking.
Wow.
Trying to decipher what they're trying to say.
I mean, aliens are probably real, but we're probably never going to see them.
Yeah, I can't say I blame them. What was it called? Non-linear... The aliens' language in the movie, like it was non-linear... Shit, I forgot. I don't remember. But it was... The syntax wasn't bound by time. Whatever kind of... Whatever that's all about.
Right.
But it was a language.
Sure, exactly.
It was a language.
Yeah. And so, like, under that definition, other animals don't have language. But then, like, you think of birds, right? And how they can in terms of noise-making abilities, they can out-noise make any other animal, including humans. Like, they can make all kinds of noises. They can mimic human language perfectly.
Oh, like parrots, like saying words and stuff?
Right. But at that point, it is just mimicking.
Mimicking.
You know, Polly wants a cracker, right?
Right.
And then it says that when it wants a cracker, so then you give it a cracker. Did that bird just use language? Well,
it might have associated, if I make these sounds, then this is the result.
Exactly. Yeah.
But there's not like abstraction going on inside their head in using this language.
Right.
It doesn't know that it's Polly.
Right.
You know.
He talks about 3 different kinds of representations. So there's like iconic, which would be literally something that looks exactly like a tree in every way, represents a tree, right? You can tell instantly by looking at it. And then there's something called like indexical, which would be you see smoke and you can kind of reason that there's probably fire.
Right.
And then the third is actual symbolic. So like something that doesn't look like a tree at all, like the word tree, but it stands in for tree, and we understand that it means tree. That's what other animals don't have. They likely have the first 2, but they do not have symbolic.
Oh, okay. Like it has to be like concrete, and with certain information they can infer, like where there's smoke, there's fire.
Right. Yeah. Exactly. And that's likely what they're doing. So like other animals do have alarm calls. So like a lot of primates, like they'll scream and they'll communicate with each other in ways that sound like or look like communication, like language. But obviously, if you were to chop those into phonetic parts and try to analyze them for actual language content, that wouldn't be there. And we humans do it all the time. The way we laugh, you can tell, you can infer, if someone walks into a room laughing, you can infer they heard something funny before they walk. Likewise, if someone walks into a room screaming, you can infer that they saw something terrifying before they walked in. But if you were to take those noises and chop them up phonetically, you wouldn't find any actual language. But it is still communication.
You wouldn't see any... morphemes and phonemes I get mixed up all the time. You wouldn't see any actual useful, meaningful language, but you could like infer just from that a theoretical,
which would be a form of indexical.
Inferring, yeah.
Right. And so I think like he basically spends the first chapter just really trying to like convince you that other animals do not have language, and that we are the only animal on the planet, likely the universe, that has language.
And this is just the first chapter. This sounds like some pretty dense material.
Yeah, no, it's great. It's really good. It's really good.
Does he mention the FOXP2 gene?
So the scope of the book, let me grab my notes here.
The FOXP2 gene, we have some weird mutation on it, and the theory goes that that's what enables us to produce speech.
Right.
And it comes at a cost, too, because other animals don't choke on their food like we do. Our larynx has to go so low in the throat in order for us to produce the wide range of sounds required to produce speech.
And I wonder, because obviously it's necessary to be able to produce these noises in order to have language. But in our early human ancestry, how much of that was used primordially? Not only is there no language in any other animals, but there's no language. There's no simple language that could have 5 or 6 symbols, and then ways that those symbols could interact with each other. That's all it would take for there to be a language. But there's just nothing.
None of that.
Nothing. But in our evolutionary past, there probably were very simple languages with just a few symbols and a few relationships between those symbols. But obviously all of that's lost to history. Unless like the old cave paintings and stuff. They probably had simple words and symbols for that.
No other animal produces language like we do. No other animal cooks food like we do.
Sure. Yeah, sure.
So there's a theory swirling around that the ability to convey ingredients for meals would have been a strong incentive to help produce language.
Definitely. And what that reminds me of? In evolution, you can't do two things. I mean, you can do two things at once. But in terms of which niche you're going to grow into, you kind of have to decide, am I going to be the kind of animal that puts a lot of resources towards chewing and digesting? Or am I going to be the kind of animal that uses its brain to cook the food, to break it down so that I can easily grow more brain tissue and more brain cells, and I don't have to spend any resources on extra teeth or guts or any of that stuff.
I think it was the crest, the skull crest for the muscles to latch onto.
The masseter.
What's
the name of that crest? Sagittal crest?
Not iliac crest, because that's
That sounds right, too.
I think that might be... No, but the skull crest for... so that the masseter muscles can latch onto it. Because we have our strongest muscle is the masseter. Yep. We have a really strong bite force as it is anyways.
I grind my teeth all night.
Yeah, I used to have canines, believe it or not.
Ground them all down.
But, and obviously, that brain power thing is a thing that outcompeted all of our other hominids who didn't have this FOXP2 thing going on.
Yeah, I'm curious about if he covers any of that.
I don't think it's just that. Cro-Magnons, unlike Neanderthals, utilized projectiles, I guess, apparently a little bit.
Neanderthals actually had bigger brains than us.
Oh.
And it wasn't the way you would think. They didn't. So what's unique about us is our prefrontal cortex. Mm-hmm. Super big.
Oh yeah.
I think at least twice as big as chimps' prefrontal cortex, and I think our brains in general are 3 times bigger than chimps or something. They're a lot bigger, and the growth was in the prefrontal cortex. Whereas Neanderthals, the part of their brain that was bigger was actually the occipital lobe, and they're known. In terms of the fossil evidence, they're known to have had an aesthetic sense for shiny things and jewelry. And it's likely that they just experienced the world in a totally different way, just saw so much more detail. And a sunset to a Neanderthal probably looked insane. Isn't that weird?
How dogs are olfactory.
Yeah.
A lot of information is dedicated towards processing through the smell, the olfactory bulb. Ours is dedicated towards language, thinking in words and language.
Vision, too. I would say that our most developed sense would be vision, but theirs is just floors ours. Just
because so much more of their neurology was directed towards processing sight.
Everything was so much more vivid to them.
Huh.
But it's likely that they did not have symbolic capability. In hominid evolution, there probably is a such thing as a small amount of symbolic representation or a small amount of language, but nothing compared to what modern humans do. Language is just nuts. His whole argument is that it is language, period. Language evolution and brain evolution together, co-evolving, got us to where we are now, which makes decent sense. It wouldn't just be, we're so smart. Well, how do we get smart? We get smart by communicating, by sharing information, by writing things down and remembering them, And then once you have words for things, you have like a way to virtually imagine, like
shorthand, yeah.
What if rock, smack, head? And then you're like, oh, kill, oh, hunting, oh.
Carl Sagan said that it's like a weird way for like us to like telepathically communicate thoughts, because you're like looking at the words that like a guy like put down, and he's like it's like Inception, like putting ideas in your head.
Right. And like, how could that not have just completely changed our trajectory?
That's definitely an advantage in a way, but with evolution, anything you gain, you're giving up something to get that.
Right.
And we needed to be able to cook our food because the brain is extremely energetically demanding, as are muscles, but the brain can't store glycogen unlike muscles, and that's why it needs a constant supply of oxygen and just nutrients, and very energetically demanding.
And we don't need to win fights hand-to-hand combat anymore. It's like even our ancestors killed from a distance.
Yeah.
We didn't have to get close.
We chased them off cliffs or use projectiles.
Yep.
We did like our projectiles.
Definitely.
And there's that gorilla Coco who memorized like 200 words.
Right.
But how well does she understand the relationship between those words of syntactic structure?
Right. And how much of it was just like kind of Pavlovian conditioning?
Yeah.
Like when you want this, then push
say
this symbol.
And it's all language production is all confined to Brodmann. No. 23 and 24, I think, is Wernicke's area, which is speech comprehension. Broca's area, also known as Brodmann's area 44 and 45, I believe, if I'm not mistaken, which it might be. I don't think I am. But it's Broca's area is the part of the brain responsible for speech production. And if you have difficulty producing speech, you probably have Broca's aphasia.
Right.
And if you have difficulty comprehending speech, you probably have Wernicke's aphasia.
Yes.
Does he mention any of that? He'll probably dive into it.
Simpler language likely existed in our evolutionary past, and the benefits of the ability likely led to rapid selection and growth in this niche. The incessant demands of efficiently reconstituting a symbolic system in each generation would have created selection pressures to reshape our lineage's ape brains to fit this new function. If what is most peculiar about language is its symbolic basis, then whatever is unique about the human brain must reflect this. The way birds reflect the aerodynamics of flight in the shape and the movement of their wings. Human brains are 3 times larger than they should be for an ape our size, and size is only the most superficial symptom of substantial reorganization at deeper levels. Radical reengineering of the whole brain has taken place on a scale that is unprecedented. Interpreting these differences as consequences of the functional demands imposed by aeons of language processing may offer new insights into the relationship between differences in cognitive function and differences in large-scale brain organization.
Those abstract sounds you just produced did happy, fun things and excited things to my Wernicke's area.
Isn't that nuts?
Yeah. And then we're talking, hey, look at how cool our brains are. It's like so much real estate is dedicated towards just language, and that's like kind of the world that we habit like in our heads too, with abstraction and all that.
Right. There's like philosophers, when they talk about this, they refer to phenomenal consciousness kind of as the experience itself. And then there's something called access consciousness, which is sort of us reflecting on our experiences and kind of imagining future experiences. And I wonder, if animals really possess any access consciousness, or if it's all just phenomenal consciousness.
Most of their neurons are dedicated towards the peripheral nervous system, though. There's not a whole lot of weird. That is really weird. And they're so depressed because they're not sociable. Because when you get like brain action, and we're hopelessly dependent on being sociable.
So when like octopi use ink, I always imagined that it was to cloud the water,
so they could get away.
Right.
But it's not?
I saw this insane video of like an octopus. Because they have camouflage. A lot of them have camouflage too. They can change their color.
Chromatophores or something shit like that.
It was being chased by another animal, another fish. And then it changed. This was all kind of like one after another. It laid flat, changed its color to appear the same as the ground.
They're good at that.
And in the same motion, shot a squirt of ink to the right. And it looked like a shadow of an octopus. And then the real octopus went off to the left. It completely completely misdirected this.
If you find that video, you have to show me.
Fucking
You'll
nuts.
Now that kind of behavior.
You'd think it would require some sort of understanding of current states, future.
Want to make himself look like a clownfish or something weird?
Right. And then like insects do that. Like some insects.
Mimicry.
Right. And like that's not a conscious process.
No.
So I just wonder.
It's just a thing. Like if my wings also look like eyes, I'll be less likely to get eaten.
But they never have that thought. Just over time.
No, yeah, that's wings genetics.
That look like eyes.
That's genetics at work. There's no thought involved with that. That's just genetics at work.
And that's what I wonder. Like, what were the primordial things that led to, like, our wings of our brain developing eyeballs, which would be like symbolic understanding. There's an obvious benefit to any animal that could do it. Like, imagine how much more successful any species on the planet would be if they could communicate symbolically the way we can.
Oh,
it would be so beneficial for any species.
What if ants evolved that ability?
Yeah,
they would just take over the globe instantly.
The way they communicate's really interesting, actually. Like the emergent behavior of an ant colony, they like secrete things out of their butts like as they're walking.
And a lot of it is
It's like an exploratory process. So like 1,000 ants will all go out and then all come back. But the one that comes back with food, they will have left a trail that's different from
that's
all
saying,
the others.
hey, there's food.
Yeah,
that's kind of
like
how a brain works. Like, like one neuron will have 10,000 dendrites that shoot out a signal.
Right.
And the one signal that shoots back the loudest gets that signal.
Lightning works like that too. It like splays out till it...
But with ants, it's the path of most opportunity. Hey, there's food this way. Let's go this way.
Right.
That's how ants kind of more or less work like a neuron outside of a brain. Neurons outside of a brain, more or less.
You could even say that the ant itself isn't the animal. Like the colony is actually the animal.
Yeah. I like that.
Yeah.
It's no single thing, but it's built upon like specialized nodes, and obviously the queen is the center.
And you know what, this ability, it sounds great, right? And it is great in a lot of obvious ways, but there's a lot of pitfalls too. Like if you think, like all you have to do is become convinced of something, and then a word takes on a new meaning, and it just becomes your new reality. There was something called the morning star and the evening star, and they had two separate names, the morning star and the evening star. And forever,
I think Venus is one of them.
And forever, people thought they were two different things. Come to find out, Venus was both of them.
Oh.
So now, this thing that was two separate things symbolically in our minds because we had somehow convinced each other of it, were actually one in the same the whole time. So we can generate flaws in reasoning through our symbolic tendencies.
Yeah. The tendrils can get kind of twisted.
Right. And he uses an example in the book where you call mosquitoes, right?
Right.
And they are what they are. They are that experience of a tiny bug that bites you and it itches and it's terrible.
Causes malaria.
If you were to find out that actually mosquitoes are tiny listening devices released by the CIA to record conversations, that would change the definition of what a mosquito is. But it wouldn't change anything about the phenomenal experience of mosquito. That doesn't change. So if something can change so radically but still maintain the same symbolic relationship, like what the fuck is this? What is symbolic? You know, like what does that even mean? Or if something
tentative,
right? Like I mean, it is tentative, but it doesn't feel like that.
No,
like to us, it all feels so concrete, but it is just a process that our minds just kind of create. It's so fucking weird to think about. So it can also lead to like. Same with the whole morning star, evening star thing. We can have one in the same person, like Charlie Kirk, for instance, that can be viewed by one half of the population as this perfect godly saint that just was a martyr.
As Martin Luther of our generation.
Right. Or another side thinks, no, that guy's like a racist, horrible, sexist person. But it's one and the same person. We just have totally different...
How people perceive...
The only way we can do that is by having a flawed symbolic or an imperfect symbolic representation system in our minds, you know?
It is... And that can divide people, and that can lead to wars easily.
Right. And when you do all of that through divisive language, That's how you convince people.
Or
That's
propaganda, as some would call it.
Right. Exactly. No, exactly.
No one's immune from it.
And we're particularly susceptible to it as humans. Like we want.
No one would ever lie to me.
Yeah. We want a nice, clean narrative.
One thing, Malcolm X was a good movie, and based on a person who said some very profound, awesome things. Like, I don't know, he learned that people of any race can be crazy assholes, but there's also good people from all walks of life. And yeah, I don't know.
It's a great book. You're going out of town soon, right?
I am.
Be able to. How long are you going to be out for?
At least 3 weeks. I've yet to buy a return ticket.
Oh boy, could be longer.
Could be longer. But I would like to spend Thanksgiving with my family.
So be back November.
Maybe. I'll think about it.
Just
I'll cross that bridge when I come to it.
Come back in a month. I'll read chapter 2, and then we can do the next episode.
Yeah, sounds good.
Well, that wraps up the episode. If you like what we're doing, let us know. And also, let us know what you think we should do next. I'll catch you next time.